In this lecture, we are going to talk about very important topic, which is arrays. Arrays are nothing but collection of data. So in normal scenarios where we declare an integer, then that integer is capable of storing a single data value. Now suppose if we want to store multiple data values, in that case we will require some type of storage which can store those multiple data values. Arrays can alternatively also called as sequential collection of same data type. What that means is I can have multiple integer variables clubbed together which can be called as a collection of same data type. So in this example, I am using this variable x, which is an array of size 4. So this is collection of a data type which can store 4 data values. All array variables will have an index which are used for accessing and storing values into those array variables. So if you have arrays of size 4, then its index will start from 0, then 1, 2 and then 3. So all array indexes will always start with 0. So why do we need arrays? Let us take one hypothetical example where you are required to declare hundreds of variables. In that case, instead of declaring those variables like this, marks1, marks2, marks3, you can alternatively use arrays like this. So I am declaring a variable marks with size of 3. So here marks will have these 3 variables as a collection called as arrays. And all these 3 individual variables can be accessed using their index. Again, just to revise, X is an array which is a collection of same data type. Here in this example, I am using X as an array of size 4. So X0 is my first element and x3 is my last element. In the next lecture, we will check how we can declare, initialize and use arrays in a program. In this lecture, we are going to talk about declaring, initializing and accessing array elements. The topic name is single dimensional arrays. So normal arrays with a single index that we define are called as single dimensional arrays. In the next lecture, we are going to check what are multi-dimensional arrays as well. But for this lesson, let us keep our scope limited to single dimensional arrays. So let us first check how we can declare arrays. So syntax is like this. You need to specify your data type like int, float or char. Then you need to add your variable name. So all the standard rules which apply to declare a variable will also be applicable to declare array names. And then inside of square bracket, you need to specify array size. So here is one example. I am declaring an array of type integer, naming it as marks, and I am specifying array size as 7. So I am declaring collection of 7 integer variables, marks 0, 1, 2, 3 and so on till marks 6. So total 7 elements. Similarly, in the second example, I am declaring an array of type float, naming it as averages and setting array size as 10. So it will be an array of 10 float variables. So once declaration is done, let us see how we can initialize arrays. Here I am declaring an integer array as marks, initializing it with setting data size as 7, and to initialize an array after equal to sign, you can specify all the possible values inside of curly braces. So for integer array of 7, I have specified 7 integer variables over here. Alternatively, if you are going to specify explicit 7 values, then you can skip specifying array data size. So compiler will automatically initialize array marks with the data size of 7. Hence the compiler will allocate 7 memory locations to store these data values. So when these type of declarations are done, then your arrays are stored sequentially like this. So this 10, 20, 30 are data values and these are address locations. So if integer requires 4 bytes of data, then this address location plus 4 plus 4 plus 4 and so on will be total storage required for your declared arrays. Here is another example where I have declared a character array with data size as 2, naming it as options, and I'm initializing it with T and F, which is short form for true and false. Also notice that I have specified these values inside of single quote because those are character values. Now let us check how we can access array elements. Array elements can be accessed via their index value. So by specifying an index, you can access that particular array element from the collection. So in our previous examples where we have initialized array marks, so this is my index 0, 1, 2, 3, 4, 5 and 6. So marks 3 is representing value 40. So in this statement, compiler will print 40. Similarly, in this arithmetic statement, marks 0 is representing 10, marks 1 is representing 20, and marks 3 is representing 30. So 60, which is result of this addition, will be stored into total. You can also traverse array elements using another variable. Like, to traverse all array elements, I'm using a variable I, initializing it to 0, and I'm writing a condition where I is less than 7. So this loop will be performed in the iterations 0, 1, 2 till 6, because 6 is less than 7, that is the maximum possible value for which the condition will hold true. Once I is incremented to 7, 7 less than 7, which will be a false condition, so this for loop will terminate. So for these 7 iterations, what we are doing, we are adding marks into previous value of total and storing the result again into total. So in the next iterations, total gets updated. So in this for loop, what we are doing, we are traversing this whole array collection and adding these each element. So at the end of this program, total will have total of all these elements. So at the end of this for loop, total will have addition of all these data values. In the next lecture, we will check few programs on single dimensional arrays. Now we are going to check few programs on single dimensional arrays. In this program, we are going to accept an array from user and simply reprint it. So these are our header files. This is our main array which we are going to use to store values and reprint it. I will be my index variable and n is the number of array elements that I'm going to use in the program. I'm declaring array variable of integer type with size as 20, and I'm asking user to enter n. So that will be the number of elements that user is going to enter. So suppose user has entered 5, then 5 will be stored into address location of n, and then I'm asking user to enter array elements. So as we know that array starts from 0, so my loop is from 0 till n. So if I have entered 5, so this loop will be from 0 till 4 because of this condition. So I less than 5 will be the condition, hence loop will start from 0 and it will go till 4. So inside of for loop, I am printing enter element %d and replacing %d with I plus 1. So in the first iteration, when I will be equal to 0, it will enter element 1. I'm writing I plus 1 so that it becomes more human readable. So in the first iteration, the element entered at A0 or at the 0th iteration will be read as element 1, and then in the second location it will be 2, and in the third location it will be 3, and so on. And then we are going to scan the value from user and store it at address location of A of I, that is A0. So in the first iteration, whatever the value user enters will be stored at this location. Suppose user has entered 10. Then in the second iteration, enter element 2 will be printed and value will be stored at address location of A1. So 20 will be stored. So similarly, our loop is going to execute till 4. So suppose user has entered 30, 40 and 50 in the subsequent iterations. After that, this loop will be completed, and then again we are writing the same loop. So we need to print these values. So again, I am using the for loop starting from 0 till 4. So these all indexes will be executed. So inside of this for loop, there is a single statement. So without curly braces, I am writing printf element %d colon %d, and then I plus 1 will be replaced over here and value of ai will be replaced over here. So in the loop, compiler will print element 1 is equal to address location of 0, that is 10, because this is our first iteration. So I plus 1, that is 0 plus 1, hence 1 will be printed over here, colon a of 0, which is 10, hence 10 will be printed. And then in the next iteration, on the next line, because of this slash n, element 2 colon 20 will be printed, and similarly in the subsequent iteration, element 3 colon 30, element 4 colon 40, and finally element 5 colon 50 will be printed on the output screen. In this program, we are going to ask user to enter array elements, and then we will print these array elements into reverse order. So like the previous program, I am using array element of size 20, and n will denote the number of array elements that user wants to enter. I will be my index variable. I am asking user to enter n, and then those n number of array elements I am going to accept from user. For that, I have written this loop. So for I is equal to 0, I less than equal to n. So if user has entered, let's say 5, then this for loop will execute for 5 times starting from 0 till 4. 4, and then I'm going to accept these array elements, and those values will be stored subsequently starting from array of 0, array of 1, array of 2, and so on till array of 4. So suppose user has entered 10, 20, 30, 40 and 50. So in order to print in reverse direction, our second loop for printing these array elements to start from this value, that is n minus 1, because n was entered as 5. So starting from n minus 1, the loop will go till 0. So this is our second for loop to print array elements in reverse order. I am starting I from n minus 1, and the condition will be I greater than equal to 0, and I will be decremented on each iteration. And inside of printf statement, I am using /n for printing each element on next line, and the string is printed as element %d :d. There I am going to print first parameter as I plus 1. So I plus 1 will be replaced over here, and a of I, which is array element, will be replaced over here. So output will be something like this. First value is n minus 1, so that is 4. So output in the first iteration will be element I plus 1. So current value of I is 4. So 4 plus 1, that is 5. So element 5 : a of 4, that is 50. Then on the next line, element 4 : 40. Again in the next iteration, element 3 : 30. In the next iteration, element 2 : 20. And in the final iteration, element 1 : 10. That is the first value from our array elements. Important point to notice over here, though we have initialized array with 20, we are not utilizing this space at all. So technically, user can enter values up to 20. So there's only possibility of storing 20 array elements in this program. However, user can enter 100 also over here, but on the 21st iteration, compiler will give an error in this for loop. At the end of this course, we are going to have few lectures on few advanced topics. So in one of those topics, I'll explain you how we can declare dynamic arrays. So user can enter elements of any size that will depend on his choice. In the next program, we are going to print addition of all the array elements given by the user. So like previous program, I am using similar set of variables, plus I am adding variable as sum equal to 0 to add up all the array elements. So here I am asking user to enter n, that is number of array elements that user wish to enter. Then this is our standard for loop that will take all the values from user and store it into our array elements. So suppose user has entered n equal to 5, and he has entered 10 to 20 into these array elements. So to add all these elements, we need the same for loop starting from 0 till 4, because n is equal to 5 and condition is used as less than 5. So this loop will execute from 0 till 4, and then inside of this for loop we just have a single statement wherein we are going to write sum is equal to sum plus current value of array elements. So starting from a of 0 till a of 4 will be added into sum. So in the first iteration, sum will be stored current value of sum, which is 0, plus a of 0, which is 10. So sum will be changed to 10. Then in the second iteration, sum will be stored as sum equal to current value of sum, that is 10, plus a of 1, that is 20. So sum will become 30. Similarly, in the second loop, this 30 and this 30 will be added. So sum will become 60. And then in the next iteration, 60 and 40 will be added. So sum will become 100. And in the final iteration, current value of sum, that is 100, will be added with next array element. And finally, sum will become 150. After that, this for loop will be completed. And finally we will print sum of given array elements is %d, and here sum will be printed instead of %d. So output will be 150. So final output would be sum of given array elements is 150. In this program, we are going to print Fibonacci series but using arrays. I'm using array of size 20. Then n is the number that will be entered by user, which will denote number of elements that will be using from this array, and I is my index variable. So I'm asking user to enter n, and after that, because we know that first two elements from the Fibonacci series are 0 and 1, so I'm initializing a0 with 0 and a of 1 with 1. So a0 is initialized to 0 and a of 1 with 1. So suppose user has entered 5, then because first two values are already stored, we need to calculate calculate from this location till this. So our for loop will begin from 2 and it will go till less than n. So if user has entered 5, so it will go till 4. So this loop will execute from 2 till 4. So in the for loop, we need to calculate these values iteratively. So in case of Fibonacci series, what we need to do is this element will be calculated with adding these two numbers. So a of 2 will be equal to a of 1 plus a of 0. Now in order to achieve it iteratively, here my index variable is equal to 2. So array of 2 is equal to array of 2 minus 1 plus array of 2 minus 2. So the current index minus 1 will give you previous element from the Fibonacci series, and minus 2 will give you previous element from the Fibonacci series. So your statement would be a of I, that is current index, is equal to a of I minus 1. So you get the first previous number plus a of I minus 2, you get the second previous number. So here 0 plus 1 will be 1. In the second iteration, 1 plus 1, that will be 2. In the final iteration, 2 plus 1 will be 3. And after that, this for loop will get completed. And after that, we are just simply printing values from 0 to 4 and will print a of I. So a of I, that is for loop starting from 0 to 4, is this part. So it will simply print all these array elements, which is now containing a Fibonacci series that we have calculated in this for loop. In this program, we are going to find out maximum and minimum element from the given array. So this is the standard part where we are asking user to enter n, and then respective array elements will be entered over here. So if user has entered, let's say 5, then 5 different array elements will be taken from this for loop. So suppose user has entered 20, minus 10, 0, 1 and 6 as values. If n was equal to 5, then he has entered these 5 values. So we are using these additional two variables max and mean, and once the values are entered by the user for all the array elements, we are going to initialize max and min to first array element. So I'm initializing max and min with 20 because a of 0 was entered as 20. And after that, for each iteration, we need to compare values of all the array elements with max and min so that we get maximum and minimum element. How we can do that? For each iteration, we are going to check whether if array element is greater than max, then max will be updated with current array element, and if current array element is less than min, then min will be updated with current value of array element. So we are going to check this for each array element. So in this first iteration, condition will be false because 20 greater than 20 is false and 20 less than 20 is false. In fact, you can skip this first element as an improvised solution by starting iterations from I equal to 1 because we have already considered max and min as the first array element. So in the second iteration, the condition will be checked as minus 10 greater than max, which is false condition. So max will be retained as 20 only, and because minus 10 is less than minimum, which is 20, so minimum will be updated with current array element, that is minus 10. In the next iteration, condition will be checked as 0 greater than 20, which is false condition. So 20 will be continued as the maximum element. The next condition to check would be 0 less than minus 10, that is false. So minus 10 will be written as minimum array element, and the process will be continued till the last point, and every time condition will be checked to find out maximum and minimum. So in our case, even in the next two iterations, condition will remain false. So our value of mean and max will remain unchanged. So at the end of final iteration, you will get maximum as 20 and minimum as minus 10. So once this for loop gets completed, we are simply printing value of mean and max directly. In the next program, we are going to print positive and negative numbers from the given array elements separately. So like in previous programs, I'm asking user to enter n, and those n number of array elements will be accepted and stored into array with this block. It is a standard for loop where we'll be scanning all the array elements. And once that is done, we are going to check all the array elements with the condition whether each array element is less than 0. If it is less than 0, then it is a negative number, and then we will print it. Similarly, we'll have another another for loop in which we will print positive elements, and it will loop through all the array elements, and all the array elements will be checked for this condition that a of I is greater than 0. If the condition is true, that means array element is a positive number and we will print it. So suppose user has entered 6 as value of n, then this block will accept 6 array elements. So starting from 0 till 5, total 6 array elements will be used for storing different values. So suppose user has entered 100, 20, minus 30, 0, minus 10 and 3 as array elements. Then in the second loop, we are going to print negative elements. So iteratively, we'll be checking all these values. So a of I less than 0 is our first condition. So in the first iteration, a of 0, which is 100 less than 0, is a false condition because 100 is not a negative number. So this will not be printed. Similarly, 20 less than 0 will also not be true. And then in the next iteration, minus 30 less than 0, which is a true condition. So on the output screen, current array element, which is minus 30, will be printed. In the next iteration, condition is 0 less than 0, which is a false condition. So 0 will not be printed. And in the next iteration, minus 10 less than 0, which is true condition. So minus 10 will be printed on the screen. And in the final iteration, 3 less than 0, which is false condition. So 3 will not be printed. So while printing negative elements, minus 30 and minus 10 will be printed on the output screen. Similarly, in the next for loop, we are going to check positive elements. So our main condition to be checked is a of I greater than 0. So in the first iteration, 100 greater than 0 will be checked, which is true. In the next iteration, 20 greater than 0, which is true. And in the next iteration, minus 30 greater than 0, which is false. Similarly, 0 greater than 0, which is false. Then minus 10 greater than 0, which is also false. Finally, 3 greater than 0, which is true. So in this for loop, 100, 20 and 3 will be printed. So on the output screen, because of this loop, these values will be printed, and because of this loop, these values will be printed. Important thing to notice here is that 0 was not printed by any for loop because 0 is neither positive or negative, hence it was not printed. In this program, we are going to print array in ascending or descending order. So in the program, we have array of size 20. I and j are my looping variable. I'm using max and min as two variables to store maximum and minimum value during the loop. And I'm using temp variable as a third variable to swap two numbers when it is required to swap. And n is our number where we are asking user to enter number of elements he is going to enter. So I'm asking user to enter n over here. That will be stored at the address location of n. Then after that, I'm asking user to enter all the array elements which will be stored at address location of AI. And after that, I'm initializing A0, that is first element of our array, into max. We are just initially assuming A of 0 as the maximum value. So logic for this program is that we need to check each value with rest of the elements in the array, and if we found any maximum number, then we need to swap those values. So suppose 10 was A of 0 and suppose somewhere A of 4 is 20, then we need to swap these values. So we are running two for loops on the same array elements. One is the loop of I and the second is loop of the j. So inside of the for loop, I am checking A of I is greater than A of j. If the condition is true, then we are going to swap two values. We are going to replace value of AI with value of aj, and we are going to replace value of aj with value of AI. So that is happening over here. So once this loop gets completed, what we will have is all the numbers in ascending order. So we just need to print those numbers using this for loop. Now once we will have all the array elements in ascending order, to print everything in descending order, we can just simply reverse the for loop and print. So if we just write reverse for loop of this part, then you will have the arrays in descending. Alternatively, we can write reverse of this logic. So I'm initializing min with A of 0, then I'm writing our two for loops I and j, and I'm going to check condition. If A of I is less than A of j, then we will swap those two array elements. And once this for loop gets completed, we have our array elements in descending order, and with this code we will just print all the array elements.